All right, cool kids. I know you missed me. So we are going to go over thermal energy lab Cornell notes. Okay, today I'm going to do this with you. Well, or at least I'm going to talk you through this. Now, as I'm going, I'm going to just keep talking. But if you need to pause the video to copy down the answers, then definitely do that because I'm sure I talk faster than you write. So we're going to do it in Cornell style, which is already printed out for you where the questions are on one side and your answers or your notes are on the other side. And at the very bottom of your paper, at the very end, you're going to give me like a 2 to 3 sentence summary about overall what you learned through this. Okay, so let's go to our original question. You may or may not, depending on if I was here, did a lab. Just to recap the lab, if you did or did not do it, there were 4 beakers. 2 beakers we heated up and 2 beakers we cooled down. Now, the 2 beakers that we cooled down had 2 different amounts of fluid in them. Okay, there was a large amount and a small amount. Same thing for the other ones. The one we heated up, we had a large amount of fluid and then a little bit of fluid. So we wanted to see what happened to those. Well, when we added heat to the large amount of fluid and the small amount of fluid, both the temperature increased, but the one with the smaller amount of fluid increased faster. And this one increased, but didn't increase as fast, but eventually they both got to the same temperature. Now the two ones that we cooled down, the smaller amount got colder faster than the larger one. But eventually they did get cold enough to where they were just about at the same temperature. So what are the 2 factors that impacted thermal energy in that lab? Well, they were mass and temperature. So it changed whenever we had the small amount of liquid and the large amount of liquid. That was your mass. And then our temperature was, well, one of them we heated up and the other one we cooled down. So overall, what is thermal energy? It is the energy of the motion of those particles in an object. So if you're looking at this beaker right here, all the numbers that you see actually stand for the speed of those atoms. So how fast they're moving, the kinetic energy of those atoms. Are they moving at a 10? Or are they moving at a 2? Okay, but either way, they're always moving. So if you total up the amount of atoms and how fast they're moving. So if you did 20 plus 20 plus 20 plus 18 plus 19 plus 19, add all of those together, that would give you your total thermal energy. So if the number in the beaker stands for the particles and how fast they're moving, then that would be the object's thermal energy. Thus, this is the part you're going to write down, the number of particles will greatly impact the thermal energy of the object. So the 2 beakers that we heated up, one had a lot, one had a little. So if they were both heated, they both have atoms that are moving real fast, if you add together the amount of atoms, this one might have had 1,000,000 and this one could have had quadrillion. But if you added together those speeds, you would get a much bigger number with the beaker that had more mass. So let's go to our what if question. What if you had a swimming pool and an ocean? Which one has more mass? Well, this is really easy and I'm sure you're going to get it. It is the ocean, but which would have more thermal energy? Well, the answer is also the ocean because it has so much more mass. And what you're writing is you're writing the stuff in red. So the ocean has more mass, which means it has more thermal energy because it has more atoms that are moving really, really fast. And you would add together the speed of all those atoms, which would give you a much bigger number. So here's our next scenario. What if I had 2 popsicles and they had the same exact mass? One was sitting on the counter and the other one I heated up with a blow dryer for 1 minute. Which would have more thermal energy? Well, probably the one that's sitting there melting. They're both melting, but the heat that's being applied to the one with the blow dryer is going to have more thermal energy because those atoms are moving faster. and they have the same amount of mass. So the mass wouldn't be a factor in this one. It would just be the temperature, which would obviously be the one with the blow dryer. So the popsicle with the blow dryer would have the highest temperature than the popsicle without the blow dryer. All right, last one. We're going to combine the two. What if you had a pool with a temperature of 98 degrees, which would be amazing right now? I'm sure you would agree. And the ocean that had a temperature of 82 degrees, which would have more thermal energy. So you've got a smaller substance that's hotter or a way larger substance that's not as hot. Which one would it be? The answer, and why, would definitely be your ocean. Your ocean would have way more thermal energy because your thermal energy is the total of all of those. So the ocean has a million times more amount of particles than that swimming pool. You could fit a billion swimming pools into the oceans. Okay, so if you added together the speed of every single atom in the ocean, you would just come up with a way bigger number, which means it has more thermal energy. That's it. Hope you have a good one. Work hard, stay smart, no excuses.